Thanks, Scott. Welcome, everybody. Thank you for joining this morning. My name is John Handler. I'm a solutions architect with AWS. We're going to look at how to secure your Amazon Elasticsearch Service domain. So Elasticsearch is a tremendously popular piece of software. I imagine many of you have heard of it or know what it is, but I thought I'd take a moment just to recapitulate a little bit and talk about Elasticsearch and Elasticsearch Service so that we all are on the same page with respect to how to secure it. Elasticsearch came out in about 2009. Originally, it was a text search engine, providing an experience much like you get with Google or on Amazon.com when you search for products over a catalog of products. Its features and the features of a search engine really are to support natural language-based text search across a corpus of documents, like an e-commerce catalog. So as such, there's an inherent notion of relevance. Your customers need to find exactly the right product. You need to be able to build complex queries and handle all of the features of natural language to provide good, rich search. As Elasticsearch was out there, people found that it was pretty useful to put log data into Elasticsearch. If you have 10,000 server logs and something goes wrong on in your software or hardware, you maybe are facing a long night of grepping terabytes of data. Well, alternately, you can throw all that data into a search engine and search for log lines and find out exactly what's going on. Now, as that was extant, there were additional open source products, one of them called Logstash, that made it easy to ingest log data into Elasticsearch, and another one, Kibana, that made it easy to take that log data and visualize what was in there. So if I wanted to have a graph, say, of the errors that I was receiving on my servers, I could build that pretty easily and then have a forest view of what was going on with my application. So we brought out Amazon Elasticsearch Service in about 2015, and this was really our way of bringing AWS management to the running and operating of Elasticsearch. Amazon Elasticsearch, fully managed service. You go to the console and you can deploy what we call an Elasticsearch Service domain. We take care of getting the hardware out, putting it together into a cluster, monitoring, sending monitoring data, and running that cluster for you in the AWS cloud. So just looking at the service itself and some of the things that we provide, number one, Amazon Elasticsearch Service supports the open source tools and APIs that you're used to using. So if you're using Logstash or if you're using Kibana, Elasticsearch Service ships with Kibana. You can connect your Logstash to it. If you're already using Elasticsearch, Amazon Elasticsearch Service is a nice drop-in replacement. We make it easier to use. So again, you use console, SDK, CLI, what have you, a few clicks of the mouse, and we go off and deploy a bunch of hardware, software, turn it into a cluster, and make that cluster available to you through an endpoint, which is a DNS entry. We make it easy to scale your Elasticsearch cluster. If you have an Amazon Elasticsearch Service domain up and running, a few clicks of the mouse, or again, an API call, and we will seamlessly change the configuration of your cluster. Things like the instance types that you're using, the storage that you're using, the instance count that you're using, all of that you can accomplish simply with a few clicks of the mouse. We do provide a number of security features, and of course today we're going to go into great depth about our security features. We have high availability features that single click of the mouse, you can get your data replicated across 2 availability zones. And we have a number of integrations with other AWS services to make data ingestion easier, make monitoring easier, and make it easy to run your domain. Now, as I mentioned, when you use the service, you use either the console, SDK, CLI, CloudFormation. You issue a command to create an Elasticsearch Service domain. The service goes off and gathers hardware for your data nodes and your master nodes. We put load balancing in front of it, and then IAM is the backbone of the security model, as we'll see. In addition, we send monitoring data to CloudTrail and CloudWatch to allow you to both know the status of your Elasticsearch cluster, as well as do audit and other monitoring of the control commands. So how do people use Elasticsearch Service? So we have customers that primarily are sending data from their servers. These are just some examples of architectural patterns that people use. We have, first of all, customers putting files into S3 in a data lake kind of scenario. Those are picked up usually by Lambda and delivered to Elasticsearch Service. We also have people using Elasticsearch in conjunction with a database to provide the kind of search that we talked about originally, the full text search. You can connect up your DynamoDB table, for instance, via Dynamo Streams, stream all that data into Elasticsearch Service, and then have a search experience on it. And then finally, we have customers with tons and tons of servers. They're flowing that data into Elasticsearch Service, potentially with Kinesis Data Firehose, sometimes with Kinesis Data Streams and Lambda, a lot of different ways to get those server logs into Elasticsearch Service. And then on the front end for that, we have customers using Kibana to visualize the data in their logs. So this is a quick example of CloudTrail data. I just thought I'd give you a feel for what Kibana looks like. On the top, we have overall a graph that's showing the regions and calls that I'm making to my AWS resources. So again, CloudTrail, for those who don't know, is a service that allows you to receive monitoring data about changes that are made to your AWS resources. There's a very simple integration that allows you to take that CloudTrail data, flow it into CloudWatch logs, and then flow that into Elasticsearch Service. If we visualize that data, here we can see again at the top, we have a regional breakdown of the traffic to AWS. We have an event count, and then we even have a breakdown into a pie chart of sources and regions and API calls that are made. We have some error codes on the bottom left, and actually we have a breakdown of the calls that are made to EC2 only. So I can filter in and I can view this data about specific services to see what calls are being made to those services. And this is an example of a typical example of the kind of monitoring that people do. If we look at our leading use cases in the log space, we have a couple of different scenarios that our customers are using. So first of those is for application monitoring, root cause analysis. In this scenario, you're flowing data from your server logs, and you're making sure that your servers are up. Sometimes you're measuring traffic. You're measuring visits to your web pages. You're looking for common sort of keywords and things like that that will allow you to make some decisions about what's happening. Second, we have a lot of use cases in the SIEM, Security Information Event Management. So this allows practitioners to, again, monitor things for like denial of service or fraudulent uses of their software. In the IoT space, we have numbers of customers that are doing things like monitoring the temperature, humidity at different places in their fields, monitoring the usage of home heating kind of devices, etc. For business analysis, you can flow your logs into Elasticsearch Service, and you can see, for instance, regional sales, or you can see, again, how people are using or interacting with your software to make decisions about how better to build it. We have a number of different customers, and I'm not going to go into any detail here, but the point is that we see Elasticsearch used across the board for many different verticals, industry verticals, and most of these are, again, the log monitoring use cases. Okay, so turning to the topic of today's webinar, we're going to talk about security with Amazon Elasticsearch Service. And if we just go and zoom out and kind of look at the big picture to get a feel for the kinds of touch points that you have and places that you can dive in and apply different security and access control. Again, as I said, you interact with Amazon Elasticsearch Service over an endpoint. You do your setup, you do a few clicks, you get an Elasticsearch Service domain. We have an endpoint for you. You're going to send your application traffic, or you're going to send your log data to that endpoint. So what do we have that we can put between that endpoint and your actual Elasticsearch Service domain? So we're going to go from the inside out because it's a little bit easier to understand. IAM and IAM policies provide the main means of doing authentication and access control for your Elasticsearch Service domain. That IAM policy can apply to the domain itself. It can apply to the users or roles that are sending data to Elasticsearch Service, and you can put policies in all of those locations to provide differential access control for different roles. Beyond that, your endpoint itself could either be on the public internet. In other words, your endpoint will be a DNS entry that resolves to an address on the public internet, or your endpoint could be resolved within your VPC. If it's within your VPC, you have additional means of shaping the network traffic that goes to that endpoint. And then finally, in specific for Kibana, you can use Amazon Cognito to create a sign-in experience for Kibana where your users can authenticate, and then you'll apply a policy via Cognito to those authenticated users that can control how they access the endpoint. And a final feature that we offer in the security realm is we offer KMS for encryption at rest. KMS integration for encryption at rest, I should say. Okay, so since IAM policies are really the core of the access control, we're going to go into depth about the policies that you can write and how to write them in different scenarios. So stepping back, if you have a public endpoint, again, your IAM policy is going to be your only means of gating access and doing authentication. So there are a number of different scenarios where that's in play. If you're sending data through Kinesis Data Firehose, then you're going to use an IAM policy to control the indexes that you can write to and how that data is going in. Always with Kibana, for the second case, with Kibana, you're going to use IAM policies either in the first case with a user or in the second case with an IP address to specify the authentication for that traffic. And you can specify that for that traffic. We also have a lot of access via Lambda. So we mentioned a couple of them. If you're sending data to S3, you're going to forward it with Lambda. If you're using Dynamo Streams, you're going to forward it with Lambda. API Gateway, you're going to forward it with Lambda. And finally, you have just straight up code access, where your application itself is building and executing queries, usually against your Elasticsearch cluster. So let's see how we can set up policies for these different scenarios. So the first one is, I just want to look at the policy overall and sort of walk through what are the components of that policy. So within your IAM policy, you're going to specify an effect. This is going to be allow or deny. Now you may have pulled out in my prior discussion, there are two fundamental ways that you can provide authentication. The first of those is by specifying a principal in the policy, in which case you'll use SIGV4 signing by that principal to send your traffic, and that will authenticate. The second of these is to use a condition. The condition is an IP address or sitter block where traffic originating at that address, and it can be anonymous traffic, does not have to be signed, is able to access the domain. In terms of what you can control, we have actions and resources. So the actions include not only the HTTP verbs that are part of the Elasticsearch API, but also the calls that you make to the control plane for Elasticsearch Service, things like creating domains or listing domains. The resource allows you to say which indexes or which domains this policy applies to. So as you send your data in, it may go into, say, a search index. You want to specify a read-only access to that search index for your application. So let's look at a couple of examples. As I said, one of the primary choices you make is whether to have a public or a private endpoint. So for public access, specifically, whether you're going to have a public endpoint or whether you're going to have a IP-based access. So for a public access, then we add a principal into the policy. In this case, username 1. All requests must be signed, and they are signed with username 1's access and secret key. And those signed requests are then authenticated by IAM, so that user is then allowed to perform these actions on these resources. In this case, ES star means it can do everything, and in this case, we're sending onto a test domain, so in that domain, it can do anything. In contrast, if you pick the IP-based access control, in this case, we're specifying a condition, which is an IP address. In fact, it's a sitter block. And any traffic that originates at 1.2.3.4, the /24, the sitter block here, then is authenticated, can perform the action against the resources that we specify. And this, again, we specify can do all ES actions to the test domain. And you'll see here we've left the principal as AWS star. That's because the authentication here is based on the originating IP of the traffic. We're going to give a quick example of this and break it down a little bit more. So let's imagine that we have an application here, and in your application, you're sending some traffic to do search. We can imagine that this is a, say, movie search or an e-commerce search application. So I have a search domain that is mirroring what I have in an RDS database. My database contains my data of record. I have an updater process that's going to keep my search index up to date. And my application also has to access that to send search queries. Then I simultaneously have a monitoring domain that's receiving logs from my front ends, potentially also from my search engine. So in this case, I have a proxy that is going to allow my administrators to connect via Kibana and see what's going on in my logs. So let's see how we would write policies in this case. So here we have a table of the different actors and what are the kinds of policies that we want to put for them. So I have my administrator. This is the person who's setting up the application. That person needs to be able to do control actions and probably needs to be able to monitor. So in this case, I'm going to use a principal-based policy. I'm going to specify actions like create domain, describe, delete domain, etc. And I'm going to put that policy on both the search and monitoring domain. So for my IT or DevOps folks, they not only need to be able to do some administrative actions, but they also need to be able to call the normal Elasticsearch APIs. And again, I'm going to use a user-based policy here. I'm going to add a principal. I'm going to do those actions, get, put, delete, post, and they'll be able to describe domains and list domains, do some tagging, potentially update the configuration. And that's going to be both my search and monitoring domain. For my application, then, I want to be able to get from the search domain so that I can send queries. So in this case, I'm going to use a policy that is going to allow get against search, and I'm going to use a condition. Whether this is going to be some kind of ELB based IP address or whether this is going to be something that is specific to my application, I'm going to use some sitter block that's going to allow this application to authenticate. My updater needs to read my database and write that data to my Elasticsearch Service domain. In this case, we're going to allow post. So this is a write-only policy. It's going to be on the search domain. And again, I'm going to do it based on IP address. Finally, I have my proxy, which allows my DevOps and IT folks to view what's going on with Kibana. In this case, I'm going to allow them to get, and I'm going to allow that on the monitoring domain, and I'm going to give the IP address of the reverse proxy I'm using to access the domain. So for setting up these policies, fairly straightforward, but worth spelling out. For the administrative access, again, I'm using a principal here, and I'm allowing the actions to the control actions, and I'm allowing those on the search and the monitoring domain. And I've given them access to all of the indexes in this case. For my DevOps folks, again, those are the people who are going to be connecting with Kibana to monitor what's going on with the application and with the infrastructure. I'm going to add in to the prior policy ES HTTP star. This allows them to send Elasticsearch API calls and allows Kibana to interact with the domain. I am again using a principal here so that it is tied to a particular user, and the resources here are both the search and monitoring domain. For the application, again, what I want here is a read-only policy so that my application can send queries but not update my domain and not delete my indexes, not do anything else. So in this case, I've allowed HTTP GET only, and I'm sending it to the search domain, that's my resource, and I'm using the IP address of the application instances. And again, if you have some proxy or some other way of gating that traffic, that's what IP address or IP addresses you would use here. Now, we've talked about a number of different policies and a number of different places that they can attach. And to understand how the authentication and access control works, we have to go a little bit into the IAM policy application and resolution. There are two kinds of policies that we consider. The first of those is called a user-based policy. User-based policies attach to individual IAM users, or in some cases, you can put a policy on a role, and that role will attach to a particular EC2 instance. Apart from that, you can also write an IAM policy, which you attach to your Elasticsearch Service domain. So you could put the policies that we've talked about could apply either to particular users or roles, or to the domain itself. And it doesn't so much matter where they go, because when a request comes in, IAM is going to authenticate and provide access control based on the union of all policies that are in play for that request. The first thing to say at a high level is that deny always wins, and deny is the default. So in order for a particular action to be granted, allowed, there must be a policy somewhere in play that allows that action. Now, if you have it, we have two classes of policies. Again, we have user-based and resource-based. User-based, again, applies to a particular user. Resource-based is applied at the domain. So you can see the allowed actions are really the ones that are allowed in one of the two locations, but not mentioned in both, right? So if it's allowed in a resource-based policy and allowed in an identity-based policy, it's allowed. If it's allowed in a resource-based policy, but neither allowed nor denied anywhere else, that's allowed. And then if it's allowed in an identity-based policy and the resource-based policy doesn't mention it, that's also allowed. So up to this point, we have talked only about public endpoints. Now, you can also create your Elasticsearch Service domain with an endpoint that resolves within your VPC. This gives you additional ways of applying access control to the traffic that's coming to that domain. So let's talk about that. And again, we have customers who are sending data in various different scenarios, and these are some of the ones that we see very commonly. Perhaps you're using Kibana and you want to talk to your Elasticsearch Service domain that is in a VPC. The common way to do that is to provide a proxy or a bastion host within your VPC so that you can send that traffic to Elasticsearch Service. Also, as we mentioned, quite frequently you'll have your application inside your VPC. So you need to be able to get traffic from your application itself to the Elasticsearch Service domain. Within your VPC as well, you have log delivery scenarios. Very typically, if your application is in your VPC, your logs are going to be in your VPC, and you'll need to send those across to Elasticsearch Service. And then finally, as a sort of subtopic, we frequently see Logstash used to deliver logs to an Elasticsearch Service domain, and again, all happening within the VPC. So let's have a look at those. When you launch Elasticsearch Service into your VPC, then you have, we support that through allocating ENIs, Elastic Network Interfaces, within your VPC. Generally, the ENIs are one-to-one with the data nodes. However, we do ask that you reserve 3 times the number of data nodes worth of IP addresses for IP space within your VPC. So a best practice is to deploy your Elasticsearch Service domain into a subnet of its own that has a large enough IP space to be able to support the number of data nodes that you have. Now, within that subnet, you have a security group around the ENIs, and that security group allows you to shape the traffic that can get to the Elasticsearch Service domain. The final thing to say is that, in fact, the shaping the traffic is there, but IAM policies are still employed, and you can still use IAM policies to specify read or write access, as we did with a public endpoint. To look at the sort of simple example, here we have an application inside the VPC. It's talking to an RDS instance. There's a gateway there so that it can talk to the internet. And that application is sitting in its own security group. Then we have our deployment of the Elasticsearch Service domain. That is via ENIs. Those are in a security group. In this case, we have a single availability zone deployment. And traffic then can flow from the application security group into the ENI security group. So the Internet Gateway then provides access for your application users to do the search, for the DevOps and other folks to do their monitoring within the subnet. The security group itself has normal inbound, outbound rules. Elasticsearch Service uses port 80 and port 443, so you can allow traffic to come through from that other security group. And then we don't need SIG-v4 signing in this case because we have our traffic limited to what is already within our VPC. So there's already a security layer in place there. Again, just looking a little bit forward and into a 2-zone example. If I launch my Elasticsearch Service domain into 2 zones, I then have 2 different subnets, and I have 2 security groups here, one for each subnet. I usually, in this case, will have some public subnet where application traffic is coming in, and via the API gateway. And in this case, I'm probably going to be using IAM policies as well. Again, the zone awareness enabled puts me into 2 zones. IAM gives me security for signed requests if I want them. And then a final look at logging within the VPC. So again, I will typically have a number of different backend servers, EC2 instances in my VPC. Very commonly, people will run an open source software called Beats on their application instances. Beats is a simple log line transfer program. It really just tails a log file, sends that data off. One of the patterns for delivering that to Elasticsearch Service is to use an ELB in front of a set of Logstash instances. Logstash reads the log data, transforms that log data into the format that Elasticsearch needs, and sends it off to the domain. I use Kibana, and then I have a Bastion host. I SSH into that Bastion host. My IAM policy allows traffic from that, or I simply use my security group to allow traffic to come from the Bastion to the ENIs. So Logstash generally will be co-located with the infrastructure you're monitoring. An ELB across an auto-scaled set of indexers is a common way to go, although there are many, many different patterns for this. And then use a reverse proxy or a Bastion to get your traffic to Amazon Elasticsearch Service. One special case that I wanted to go into was doing access control for Kibana. And what we see here is we frequently have customers, and you may need to just have an ad hoc dashboard up, or you may need to have your IT folks have a dashboard across a number of different applications where those applications are in VPC. And in this case, sorry, not in VPC, for public endpoint. In this case, there are some signing proxies out there which you run locally on your laptop. Those signing proxies take all the traffic and add AWS Sigby for signing based on the way the account that's configured on your laptop. And they send that to Elasticsearch Service. IAM in this case is the main method for providing authentication and access control. I have on the bottom there an example signing proxy. This is provided as is with no guarantees. I have used this one and it has worked for me in the past. It's pretty convenient. You drop it onto your laptop, pop open your browser and go to localhost 9200, and you're then talking to your domain. I'll leave that for 1 second if you want to copy it down. And we will be sending out the slides. So within VPC, again, we've mentioned this, but if you have a VPC endpoint, you very often want to get Kibana traffic to that endpoint. And the usual way to do that is with either a proxy or a Bastion. Traffic goes to the gateway. You usually SSH tunnel to your Bastion, or if it's a reverse proxy, you just forward that traffic to Elasticsearch Service. Last thing I'll mention is recently we released integration with Amazon Cognito that provides a sign-in experience within Kibana. This works both public and private endpoints and allows you to, again, take traffic and you have a login dialog within Kibana itself. Your users will then authenticate within Kibana. Cognito will assign them a role, whether it's a default authenticated role or whether you've used Cognito to integrate with your federated identity provider. The role itself will specify which indexes, which actions that user can perform. There's one limitation at present. Because of the way Kibana sends traffic to Elasticsearch Service, at the moment, the limitation is that you can only specify a domain-level access control. For much more information on Cognito and to learn how to set it up, I have a blog post that I wrote that guides you through that. Here's the URL for that. You can either note it down now or, again, we'll be sending out the slides. All right, moving on. Last topic is encryption at rest. Amazon Elasticsearch Service can encrypt your data at rest, and that includes either EBS or ephemeral volumes that are in your Elasticsearch Service domain. It also includes the service snapshots that we take daily. The encryption itself is integrated with Amazon KMS so that you can use your own keys to encrypt your data. You can see it's fairly simple. I just check a box and I set my key, and my data is then encrypted. At present, in order to enable encryption at rest, you can only do that when you first create the domain. So be aware, there's no way to turn this on for a domain that's already exists. So in conclusion, we covered a number of different touch points and ways to control access to your domain. We looked at Cognito, we looked at VPC, we looked at IAM, and IAM really provides the backbone of the security features for Amazon Elasticsearch Service. So digging into IAM is the place you want to go. We covered public and private endpoints. You provide access control public endpoints with IAM. You provide access control for private endpoints either with IAM or with IP-based traffic shaping. And then you can use Kibana for Cognito signing. I have a couple links in here just to grab some more information if you're interested. Again, we'll be sending out the slides, so you'll have those links. And I want to thank everybody. Before we go to Q&A, I'm going to bring Scott back. He has a couple of housekeeping notes.